Hello, welcome back. Here we are looking at another one of these Blitz to PlayBASIC translation videos. So today I was working on the identification of variables, the implicit ones in particular. So it'll pick up dim statements, it'll pick up global and local statements, but it also has to pick up variables throughout the code. Just pull up this pretty rudimentary example. So we've got our global statements, we can phrase those. Don't think we've got list support at the moment, but I think we're picking up the keyword and just storing this for later. Local's the same. We do support arrays as well, but I'm not working on those at the moment. Just been working on variables. So we've got global scope, which is this initial part of the program. They'll be all tagged as global scope, and a function here, and we've got a bit of code inside here. We've got some array stuff there. We'll just pull it out so we don't confuse ourselves. Now, things here to notice really are our usages of our variables. So I've got local declared here, my float, my string. My float has the hash symbol on it. My string, it's the first usage, so it has $sign at the end of it. And loop here has the integer tag, which is the % symbol in Blitz. But as we move through, you'll notice that I've tagged A as an integer, then I've used loop without its postfix, without its suffix. B, the same, these are all used without them. And down here we've got a string, and then we're using MyString without its $sign, and same goes to float. So previously I was talking about wanting it to pick these up and do the translations for us, so which is something you really can't just do with like a replacement. Things like the $sign here, if you just pull in a bunch of code into Notepad or whatever, just do a raw replacement, that would probably get you a long way to fixing those problems. But you'll have collisions as well inside strings and comments, etc. But for the most part, no one would care. Here's another bit of code which I actually dragged across from Facebook just before to demonstrate this in a broader spectrum. So we've got, in that language, all variables were inherently float. So here I've just added a local statement with the variables in it, but left all of the occurrences throughout the program without the hash symbol on them. I've done that intentionally because I want the converter to pick them up and do that work for us. So I'll just hit save on that and close it. Go back to here, back to PlayBASIC. Now, this is the example we're loading and running. Run and debug so we can see the output. In debug it's taking 91 milliseconds. Most of that's just text output to the console. Here's the function that's output for this last piece here. Just zoom that in a little bit. You can use the scroll function too with text boxes. You'll notice that all of the variables that follow here, so after a declaration up here, the original code was just width, etc. All of these are now ready to run pretty much in PB, which is pretty good. That saves us a lot of messing around. I won't say it's going to be perfect. There's probably some situation where it will do the wrong thing or whatever. At the moment, that's more likely than not, but that will give us code that will almost run in PB as it stands. Almost. This is actually using radians rather than angles, so we have to convert these two. That might be something that we need to do in Blitz as well. I'm not quite sure if the cos and sine functions are actually, if we need to wrap them or not. haven't tried. This wasn't Blitz code, by the way. This was something else, but I use that as a good example of how we can get to add the postfix symbols to our variables for us en masse. This is the code. This is the converted code. So it probably won't compile in PV. We've probably got some functions in there that we're not using, but we should come pretty close. Up here, this is the list of scopes we've found. So we've found what we're calling global scope, which is the entire program that's not inside a function from top to bottom. And this is my function, which is the source position there is wrong, but these are the variables that are known to be inside it. Some of these are incorrect. It's picking up some common commands that it shouldn't. We might have to do a secondary search on those and make sure that they're Blitz keywords. They should already be classified, but I think that classification is not quite working properly. Anyway, so in our function that we dragged across before, we've got all of these variables, widths, etc., and they're all tagged as being of type 2, which is a float, and it gives us an indication of how frequently the variables are used. And that's handy because we might be able to use that to give hints about, in certain scopes there are variables that are only used once, that you're not, maybe it's a typo, maybe it's something else. Give warnings possibly. So you could insert a bit of a header in front of a function, let's say, that says, with a comment that says, this variable's not used more than once or something like that. Possibly even remove it. The problem with that would be, of course, is if we've misclassified something and it turns out to be a constant somewhere else or something like that, which we don't actually support at the moment. Come to think of it. So we'll have to add support for constants to make sure, and they'll have precedence over variables as well. Because variables are kind of the lowest thing on the pecking order. But our output here, this just gives me a bit of an idea of what variables it's found within inside the scope. They all seem to be okay. If you look down the bottom here of what's in this scope here, it's picked up things like swap, do, ellipse. It thinks they're variables. They're not. Of course not. But we're getting somewhere. We're getting somewhere with it. Up the top here, picked up our scopes. I'm not sure if our searching is our scope searching is working as per Blitz, but I can update that later if it's not quite correct. As in, when you're inside a function, it's going to work out what version of a variable you're using. If the thing's declared that it's global above it, then we need to go, okay, use the global occurrence of this. So if the global was declared, let's say it was a floating point variable, and then later on using it without the hash symbol, it must update that as well, rather than think that it's a new variable inside the scope. But I think actually, even though we're not doing a full compile, we're just picking through with this logic, we should be able to get a lot of that stuff done. To be horrified, if we run it on the large code base, this takes about 10 seconds to run this. Well, I'll compile and run it just straight with no debug. So this is the 9,206 line block of code. So it's being converted in about 900 milliseconds, just under a second. that's pretty good. I'm happy about that. I wasn't expecting it to do that well. I thought it might take 5-10 seconds or something for code bases that were large. Run debug. It takes a while because it's dumping all of that crap to the console, and the console is just a buffered window. So the thing looks like it's died. As you can see, it's a lot of code. Yeah, now I can pick through the scopes and see what we've uncovered. So this function, GUI win but skin, has these variables in it. Some of these might not be variables because at the moment it doesn't understand types and the field separators and types. So it might be picking up field separators as variables. Here we've got some references to these things here. We're looking for that in the code base. Let's find the global scope. Right, that's global scope there. Got a bunch of just garbage variables up front. GUI screen width. Gee, that's surprising. It's saying that screen width is only used once. The skin variables are used. That one's used 10 times. So that includes its initial occurrence, so its declaration. I wonder if that's true. GUI screen width. I don't believe that for a second. So GUI screen width occurs yeah, it's more like it. I was going to say that can't be right. So clearly we're not fetching. I hope I'm not skipping over something there. We're not searching and finding those correctly for us. Good. What have we learnt? Well, we're kind of working, but we're kind of not working. So that's pretty much what we expect to find, isn't it? If I try this array thing, actually, I might try the array one here. Function scopes. So dimension dim. I'll call it strings 100. We'll use the example we talked about the other day. So for loop equals 0 to 100. I just want to see if it picks that up actually. Sorry, print string no $, loop. Thank you. Let's have a go. And we didn't pick that up. Oh, yeah, I know why. There's no trapping of the bracket. If it sees this keyword and then a bracket following it, it won't know what to do. And it just assumes it's an integer. And strings without that will just be integer. So in that scope, my function 1, there should be a thing called, where are we? Yeah, see that? That's some more oddities there. We're not getting both of those. We should have 2 strings if that's how it was seeing it. I had some really weird problems with this afternoon, actually. Weird is not saying the least. And I was at the point where I thought, oh no, I found another weird bug in PB. And it was right at that moment where I uncovered, oh, hang on. It's not a bug in PB, it's just I haven't initialized. Okay, so we've opened. Here's the logic here. So we scan through, we find a word, which is just any group of characters that's been classified. So we'll see a block of characters like that. There is no white space. The block of characters is alphanumeric, so you can have lowercase, uppercase, and numbers, and lower score characters as well. But I think it has to start with a underscore, or has to start with a letter. Anyway, so we're skimming through, we find our word, we go, okay, grab the token, that's our variable name. We're going to need that to search for it in a second. We grab whatever's after this thing. If this is an open bracket, which means that the character after this, so just here for example, look at the actual code again. So if we go zoom over a bit, so if we're looking at this keyword here, it'll grab the token next to it, which is going to be the bracket token. Now, what I can actually do and get away with is you have white space between these things. I think in PB generally it doesn't like that white space to be there, but in a lot of languages that are pre-tokenized and then translated, which means that the white space can just be thrown away. So it doesn't matter if there's white space between stuff, which is kind of weird. In PB we can't really do that. Well, I'm not sure off the top of my head. But anyway, so we see this keyword here, this strings keyword. And since the next token is an unknown stop character, it's not a hash, it doesn't know what to do if this is presenting as an integer array. That's why it's failing. So all we have to do here, sounds pretty crazy, it's just jump to check this variable. That's how lazy I am. Yep. So look, and there we go. We fixed one little shortcoming. So strings has been picked up as being that is the array because it's seen the next character is here, or that's the assumption it's going to make. It's a pretty good assumption, and we're looking for that in the current scope, and it's found it, so it's happy to promote it. Here we have got our strings array, and we found 2 occurrences of it. That's what we wanted. Happy days. Isn't that terrific? So it's pretty much just bumbling logic to fall through and go, okay, this is our best guess for what this keyword is. If we're building a full-on compiler, we'd actually have, as I was saying before, you grab, as you found each keyword, you then dissect what the keyword actually is. Is it a structural statement like a for statement, or a go to, or or a compare, whatever it's going to be, and then they all have a certain pattern. So a for loop has, okay, after the for statement we have a declaration, then we have an assignment, and then we have an expression, a to statement, and an expression. That's the pattern that they have. An if statement has, it's just an if and it's an expression. What we have to do is we have to break the code down. At least then if we did that, we could be type aware. This is not type aware. What I mean by that is is not aware if you, like if you go, hey, here's my string array here, and I add an integer value to it, PB is going to go, what the hell are you doing? You know, it won't have a clue. But if we write this as a true compiler, we could run through here, promote this as to be the correct array. We wouldn't have needed to do that actually. And then we'd have a string. We have this replacement here. We'd have conceptually, after we've seen the expression the first time, we pull this result, so we end up with like result string plus this integer, and then we have a bit of logic there going, okay, since it's a string mixed with integers, we're going to want to treat the string like a number, so we'll have the value of the string. You know, you could do that stuff in a translator for you, and life would go on. But in our version here, we can't do that, because I don't know what this is, right? Or what the parameters in here are. I have no idea. I'm not matching types, I'm not matching the patterns of expressions, nothing. So we can get away with a very preliminary comparative sort of replacement, but we're not going to have things that are, you know, if your input code makes no sense, then your output code won't make any sense. And in places, the output code here won't make any sense in PB, because you'll have, I noticed there's a thing in Blitz where you can do type conversions, like, you know, A equals, so you have a literal string and have it converted for you to an integer value. Yeah, it just saves having, you know, a function val, for example, you know. This is a shortcut they've added. Anyway, this is the basic logic we're just picking through here. Just a select case with if the character after our current word is this, then it's most likely this thing. Yeah, so I'll have an example statement, e.g. This word bracket if for the percent it would be this word percent hash $, etc. There should be another version here that handles the trapping of fields within types, but that's not something it even looks at the moment. We'll try and get this to work pretty well, and then we'll worry about stepping up for types. Make sure it can pick up the Blitz commands correctly, output them into a wrapped function, a format, and then try and make some simple programs in Blitz and try and get them to run. So, isn't that fun? Anyway, thanks for hanging around and listening to me ramble on, and I'll see you next time. Bye.